me to record the session. If I don't record the session, I can't upload a video for you. Okay, yesterday we talked about significant figures. Today we're going to extend that quite a bit. Now, the thing about significant figures is to measure precision on that measurement. Now, someone asked me yesterday about the R value when you're doing statistical analysis on regression analysis. The R value also is a measure of precision. It just is a different way of doing it. And if you've ever done regression analysis, you've had a stat class, for example, the R value, you get your line, and depending on how close the dots are to the line is that R value. Okay, so whenever we do any problems in this class, any word problems, there's going to be a 4-step process. Okay, the first step is, and we're in a chemistry class. If there is a chemical reaction going on, balance the equation. Now, we're not going to get to balancing equations till unit 4, at the end of unit 3 into 4. So you can skip that step until we get to unit 4. Okay, the next step is, what is given? Now, again, it's going to be a paragraph, so you have to go through that, and what information are they given to you? That's what you're going to start with. Next one is, what are you trying to calculate? So given, calculate. Then there's the setup. And the setup is a series of conversions to go from given to calculate. Now we're going to do a bunch of examples on this today, so you get the idea. Lab 2, dry lab 2, is problem solving using unit analysis. So you're going to have a lot of practice then as well. Okay, so let's take a typical problem. Okay, so how many, you can't read that. How many dozen apples are in 34 single apples? Now, most of you can do that in a heartbeat. How would you do that problem? Divide by 12. Okay. Now, you said divide by 12 immediately because you're familiar with dozen. But what if I said there are a tera or a terabyte of apples? How would you do that? Same process. Okay, so for this problem, we're going to go through the steps though. Skip number 1, number 2. What is given in this problem? Single apples. Okay, given is always on the left. And what are we trying to calculate? Dozens. Dozens go on the right. Now we have step 4, the setup. So what conversion factor do you know that relates dozen to single items? All of you know this. What's the relationship? Yeah, there's 12 of anything and a dozen, right? 12 geese, 12 students, 12 apples, 12 eggs. Okay, so we need to convert that into a conversion factor though. So the conversion factors are all fractions. Now, whenever you have one conversion factor, you have two conversion factors. So 12 over dozen, dozen over 12. Now, the trick is, which one do you use? In this case, we're talking about apples. Let's put apples here. Use the left or the right one? Okay, why the left? Okay, so if we multiply 34 apples by 12 apples over 1 dozen, okay, so we want the given to always cancel. Always, always, no exceptions. Given, always cancels. So if we were to look at an algebra relationship between, what's the answer to that hard algebraic equation? What is it? C. Because the A's cancel, right? So what cancels needs to be on the bottom. That's the given. So in this case, apples need to be in the bottom, so it cancels. And I'm going to abbreviate dozen as DOZ. Okay, now apples cancel. And what are we left with? What unit are we left with? Dozen, and what are we trying to calculate? What are we trying to calculate? Dozen, yeah. That's what we want. We want everything to cancel except what we're trying to calculate. If it doesn't all cancel, something's wrong with your setup. Okay, if this problem was worth 10 points, you get 9 points for a proper setup. 9 out of 10. Have you used your calculator yet? No, so you're getting 9 out of 10 points without touching your calculator. Now we have to consider, as always, significant figures. Okay, this is what my calculator gives me. Okay, so what do we have here? Now there's something about sig figs I haven't talked about yet. I'm going to get into it like in seconds. How many sig figs is 34? What about this? What about this conversion factor over here? There's two kinds of conversion factors. One are by definition, and the other is an approximation, an estimate. Now, how many apples are in a dozen? 12.1, 11.9. It's exactly 12 by definition. Hence, anything by definition has infinite precision. So it doesn't come into play when you're trying to calculate the sig figs of the answer. So how many sig figs are in our answer? 2 or infinity? 2, because 2 is smaller than infinity. All right, so that means that's 2.1 or 2.8 doesn't. So what you do is you do the setup, determine sig figs, how many sig figs are going to be in your answer. Then after that, you do the calculation and then round to the proper number of sig figs every single time. And some of you are going to say, why do I have to set up that problem? That was a stupidly easy problem. I could have done that in my head. You're right. But the procedure, when we get into something more complicated, you're not going to be able to do it in your head at all. You'll see some of the wild problems you'll be doing in Unit 5. They'll take half a page. Yeah.
If we have a different setup, okay, if we have a different setup, and the setup is different from your
If your setup is, I can follow the logic of your setup, is fine. But some people just write down the answer, or they'll do some little cryptic thing with no units or anything, and there's no logic there, and so I can't give you any point. But if you set it up so that I can follow your logic, that's fine. But yeah, that's the ratio. You're absolutely right. All the conversion factors are ratios. So yeah, and it depends on how comfortable you are or your background also. You know, the way you were schooled is different than this one, but you do fine. And you know, as long as it's logical and I can follow it. Otherwise. Okay, are there any questions about this setup?
Yeah,
Okay.
sorry, I missed it.
Given? Okay, so there's two kinds of conversions. One is measured, like pi. Pi is 3.14 hundreds of, okay? So that's estimate when you say 314. So then that's 3 sig figs. Something like a dozen, it's exact. And you go to the dictionary, how many are in a dozen? 12. Boom. How many feet are in an inch? I mean, how many inches are in a foot? 12, exactly, by definition. How many feet are in a yard? 3. You know, those are all infinite precision. And one other infinite is, everyone count. How many is that? 2.9. See where I'm going. Also, if you're counting like that, that's also infinite precision. And you're not going to get into that very much. When you're going to get into it are these. Now, on tomorrow's Dry Lab 2 is on the first page of your Dry Lab 2 is a set of conversions. I have modified that. I think it's much clearer because on the page of the conversions, I bold-faced all the ones that are infinite. So you know exactly which ones are. You don't have to think about it. The one in your packet, it's slightly italicized. So it's, in my opinion, it's harder to read. So if you want to look at mine or print out mine tonight and bring it in, that would work. If I remember, I'll try to print out one and make a copy for everyone tomorrow. But if I forget, you just use the one on, go to Canvas, go to Files, click on Lab 1, Lab 2, and it'll bring up the lab, and you just look at the first page. You don't need to worry about anything else. Okay, so any more questions about this? Yeah. Yeah, usually the given is not infinite. I understand your point because it's not 34.1, is it? Exactly 34. They always make you do sig figs for the given. That's a really good question, though. His question was, well, why can't the given be infinite? Because it's exactly 34. It's not 35, it's not 33. It's not 33.999. It's exactly. So anyway, but on given, do your sig figs for your given and the conversion factor.
In relation to the basket.
But some of the conversion factors aren't infinite. They're measured. And that's why my sheet differentiates that. All right, so let's do more. Now, a given can be a number or it can be a fraction. If the given is a fraction, you have to end with a fraction. Like 12 miles per gallon. Okay, but if that was the given, that's a fraction. So when you do your calculations, you're going to end up with ending with a fraction. So be aware of that. Okay, so let's go on here. Let's do a lot more examples. Now that was, by the way, that was a one-step conversion. Frequently, there are multiple step conversions. Sometimes there are a lot of steps. Like tomorrow's Dry Lab 2, you're going to see some of those problems may have like 4 or 5 steps to them. But they're all conversions and they're all cancellations. So the concept, burn it into your mind. It's called unit cancellation. That's the process. And it's used in physics, chemistry, geology, molecular biology, engineering. They all use the same thing. So having this process down will really help you in subsequent classes because they use the same thing. Okay, so let's do some more examples here. Let's see here. I'm looking for how to set up a default font. I don't see it. Oh well. Okay. I'm in Canvas now, and this is the first page of Dry Lab 2. Now, if you notice, there's boldface and non-boldface. The boldface ones are considered infinite sig figs. So for example, mile equals 1.609 kilometers. It's not infinite. That would be 4 sig figs. Inches equal to 2.54 centimeters. Boldface, infinite sig figs. Huh?
Why would it be
They just defined it that way. By definition. It's probably really close to that. And that's why they did it. Others, I did not. Sometimes when things are done in the, I don't know why they decided to do that. Also, These are all the metric stuff. And there's a fair amount of metric conversions in Dry Lab 2. So this page is very, very handy to have. So for this problem, we're going to need 2.54 centimeters per inch. Okay, so what's given? 34 centimeters. Now, centimeter, a little over 2.5 of these guys make up an inch. And some of you have used centimeters and stuff in the past, others not. Bless you. Okay, and what are we trying to calculate? Inches. Okay, so do we have a conversion factor with both centimeters and inches in it? All of you need to say yes. Okay, so we have okay, 1 inch over 254 centimeters. That's 1, and we always have the inverse. So which one are we going to use? Which one's going to cancel our given? Left one. So we want the centimeters to cancel. And so this is going to be 2 sig figs for 34. Infinite precision. That infinite needs to be more horizontal. Needs to be like this. So our answer is going to have 2 sig figs. So we now have 9 out of 10 points. Okay, so we go to the third place. That's 0 to 4. Our answer is going to be 1.3 inches. Oh, yeah. My calculator is set up to do scientific notation automatically. So it's got an E1 at the end, meaning I have to multiply that. Because it's by definition. It is by international standards. It's redefined as equal. And you look on a ruler, but so you're used to using metric system, obviously, right? Yeah. Yeah. So you won't have any trouble converting. All right. And I agree with you. It's our department says it's by definition. And so that means it's infinite sig figs. No. It's 13. 2 sig figs. You see why it's 2 sig figs? Okay. I carried the decimal. I was like, yeah. Yes. The only problem with that is, yes, but the more you use it, you almost don't need it. It depends on what class you take next. Some of them will require you to know that the metric part for sure. And on the other stuff, some of them. It just depends on the structure of the class. I like, I carry with me, this is a surprise, everyone. I carry with me 24/7 my phone. And if I need to look up how many centimeters are in an inch, I don't have to memorize it because I have my phone. That'll do it faster than me, you know. So I don't believe in memorizing a lot of stuff because you have this available. And other teachers feel differently. So it just depends on class. Like some teachers make you memorize that. You have your smartphone. And that's my philosophy anyway. So yeah. No, it's two sig figs. So you go to the third sig fig, which is the second three, and that affects the first three. And you're going by decimal places. I'm looking at the whole number, sig fig wise. Yeah. So
You
you,
have to put the decimal in.
no, you can put it there or not. I carried it, that error, I carried it through. I wanted to get rid of it. So no,
The sig figs based on the 34.
the initial 34. Yeah, exactly. It doesn't matter because it's infinite sig figs because it's defined that way. Then it's a good question. If it's not defined, then you have to look at the sig figs of the conversion. Now we're going to have a lot of conversion factors that are not infinite. We're going to do something called Avogadro's number, 6.02 times 10 to the 23rd. That's measured. So that's 3 sig figs, what I just told you. Anyway, there's some are and some aren't. That's why I gave you the sheet. So it's boldface. So you know right away it's boldface. Also, all the metric system is all by definition. So those are all infinite as well. Okay. Yeah. Yeah. No. No, because it's 30 characters after the decimal. I mean, it really goes a long time. Yeah. So that one, if you just put down 3.14 is pi, it'd be 3 sig figs because it's not by definition 3.14. It's a lot of people get confused about that in the beginning, and it's just a matter of giving lots and lots and lots of examples. Does that make sense? Better anyway. Okay, good. Okay, let's do some more here. What are we doing on time? 11:49. Okay, so let's do a multi-step problem now. Let's see. I know this seems like a math class. Unit 2 is going to start our real chemistry. It'll be very chemistry-y in Unit 2, but this is the foundation. If you take 1A, 2A, or 3A, you're going to do this, but it'll be zoomed through in about 20 minutes, what we're taking 2 days on. Well, we're going to be taking more than 2 days actually in this. But anyway, they zoom through it because they assume you already know this. Okay, let's see here. Um, I'm going to invent a problem here. um, Okay, how many miles are in 12 inches? Not very many. But how many exactly? Okay, so what's given? Okay, 12 inches is given. What are we trying to calculate? Miles. Okay, so step 4 is a setup. So what conversion factors do we have? Do we have a conversion factor that has inches and miles in it? I'm sure there's somewhere there is one, but do we know it? No. So we know do we know a conversion factor that has inches in it? What? Feet, yeah. So let's get it in feet first. Okay. So okay, now we have, after we cancel the inches, we now have feet. Do we know a conversion factor that has feet and miles in it? $52.80. How many feet is it? Okay, now everything's canceled except for the mile. And what are we trying to calculate? Miles. So we're there. Okay, so the strategy is, if you don't have a direct conversion factor, have a conversion factor that has one of them in it, and another conversion factor that has the to be calculated in it. And then hopefully in between, things cancel, so you end up in the right place. Now you can approach this backwardsly or forwardly. I just invented those two words. You can start with miles and go backwards, or you can start with inches and go forward. Doesn't matter. Unit cancellation. We got to get the units to cancel. If they don't cancel, your setup is incorrect. Okay, so we just earned 9 out of 10 points. Is 52.80 exact? Okay, so we have infinite, infinite, 2 sig figs. Now, I'm going to talk about a calculator technique. Now, some people would do this by multiplying 12 times 52.80 on the bottom and write down that answer separately. You can do this totally within your calculator. So if you want to do it totally within your calculator, which means less potential errors, what you do is think everything on the top is multiplying, everything on the bottom is divide. Because we're going to be doing a lot of problems with conversion factors in there. In other words, there's going to be a fraction bar in there. So in your calculator, you're going to go 12 times 1, which is just 12. Hit the divide key 12 and hit the divide key again for 52.80, enter. You won't have to write down anything. The calculator will keep all that internal for you. Yeah. So we're going to go 12 times 1 times 1. Okay. Hit the divide key. 12. Hit the divide key again. 52.80 equals. So if there are two numbers on the bottom that aren't one, you're gonna be hitting the divide key for each one. That means you're gonna hit the divide key twice. If there are four numbers on the top, you're hitting the times symbol on your calculator 4 times. So each number is going to get a multiplier divide. And it'll totally keep it internal, which really helps you a lot. If you're writing, you can do it another way as well. You'll be writing down numbers, you get the same answers, but the probability of getting an error by writing stuff down is higher. So as long as you can punch the right key numbers, you'll get the right answer every time. And it's much faster too, much faster. Okay, does that make sense? I go 12. Let's say there was a 4 in that. I go 12 times 4 divided by 12 divided by 5280. And it works on all calculators, including your phone, whatever. They all work the same. So it's a real nice technique to get used to. And sometimes it can be really, really long. Yeah. That's for the number of significant figures. It's, in other words, infinite. And they basically don't come into the calculation in terms of determining sig figs of your answer. No, that's just for your. I write down a lot of extra stuff just for clarity, or you don't need to write it down, but just, you should have it in your notes though, just to make sure. Yeah, I just showed you one. Yeah, it's in the conversion factors that it's either infinity or number of sig figs. It's never on the given. The given is always whatever the numbers are. Yeah. And those other two would be infinite, so they don't come into play. Okay, how are you guys doing on that? I wish they fixed this freaking clock. Yeah, I've got some of my on my laptop here, but it just bugs me because I'm used to looking at the clock. All right, so let's do a fraction input. Well, let's do another multi-step one first. Let's see here. Okay, how many centimeters are in 1.23 kilometers? Going to be a lot. Okay, so what's given? .123 kilometers. And we're trying to calculate centimeters. Okay, so we jump over to my so K is kilo, small k, kilo. Small c is centi. Now centi is easy to remember. How many cents are in $1? 100, right? That's a good way to remember centi. Kilo, more, that's being used more and more. Some of these others aren't being used very much. Um, uh, with computers, they're talking about terabytes as far as the hard drives considered. Yeah. You mean, this, okay, there's this one. An- yeah. That should be, um, it should be 10 to the ninth NG. Yeah. Yeah. So we're not gonna, I need to correct that too on the, yes. All right. So going back to, we're looking at, kilometers or kilometers and centimeters. Okay. A centimeter, centimeter. Okay. Now, the easiest way to convert in metric is to go to the base unit. So if it's a kilometer or kilometer or a centimeter, the base unit is meter. So let's go from centimeter to meter, then meter to kilometer. Now, some people are used to this can go directly, but the easiest way to migrate through metric conversions is go to the base unit. So when working with meters, it's going to be the meter, 1 meter. So how many centimeters are in 1 meter? 100 cents to $1. Okay. And how many meters are in a kilometer? 1,000. And everything in the metric system is infinite because it's by definition infinite sig figs. Okay. And I need to make, this was a typo here. This needs to be just plain G. So I'm going to correct that. And I hate typos. Okay, so again, the base unit for a kilometer is a meter. So we're going to go kilometers to meter. And how many meters are in a kilometer? 1,000 or 10 cubed. Okay, now we have meters. Now we need to go from meters to centimeters. And see how we're using the meter is in the middle. That's the base unit. So we go given to base unit to what we're trying to calculate. So meters needs to cancel. And how many centimeters are in a meter? Okay. Notice everything cancels except for centimeter. We're trying to calculate centimeters. So that setup is right. Okay. Now, 3 sig figs, infinite sig figs. So our answer is going to have 3 sig figs. So who can do this in their head? Yeah, or because 1,000 is 10 cubed, 100 is 10 squared. 10 cubed times 10 squared is 10 to the 5th. Okay, so we need 3 sig figs. My answer is already in 3 sig figs, so we're done. Yeah. Divided by 1. So it's, yeah. From from that chart? Everything's by tens, so yeah. Yeah, or powers of 10, yeah. Okay, so again, metric conversion, sometimes it's a one-stepper, whatever, but think of the base unit. So when we're talking about length, think of meters. We're talking about volume, think about liters. We're talking about what's left over. Well, there's area and volume. We haven't talked about that yet. There's length, there's volume. What's left? Yeah, area is part of length because it's length squared. Volume is length cubed. Okay. All right. Is there any questions about this guy? No, I said there are three. No, 1,000 has infinite and 100 is infinite. The given is 1.23. That's where the three things come in. Okay, so the infinite stuff doesn't count into sig fig counting, only if it's measured. Okay, one, it's metric. All the metric stuff is by definition. Just boom, that's an easy one. The other stuff, you have my cheat sheet. That's bold-faced, it's infinite. If it's not bold-faced, it's measured. Okay. Interesting you caught that error. All right. Okay, so the next one I'm going to do is we're going to start with a fraction. Now, whenever you start with a fraction, if the given is a fraction, your calculated is going to be a fraction. And the second thing is that's two built-in problems there. You have to do first the numerator, then the denominator. So it's two conversions, two sets of conversions. Okay. Yeah, if a car is speeding along at 34.4 miles per hour, what is its speed in kilometers per second? Okay, so what's given here?
24.
34. Per means fraction. Okay, per means fraction. So per hour. Hence, we're starting with a fraction. So red flag, calculated needs to be a fraction. And it mentioned here kilometers per second. Okay, and like I said before, there are two problems here. There's the numerator conversion and the denominator conversion. And it doesn't matter which one you do first. So let's do the numerator one first. We're going to get miles over to kilometers. How many miles are in a kilometer? Does anyone have that worksheet up?
I couldn't pull it up. I didn't know what 1,000 miles.
No, 1,000 meters per kilometer.
Oh, meters.
What is it? Isn't it 164 or something?
Yes.
Is it boldface? All right, so let's quickly look up. Um, okay, so notice it's not boldface. 1 mile equals 1.609 kilometers. So that's 4 sig figs. It's not boldface. Okay, 1609. I got to remember that now. Okay, so it's okay. So we have miles canceled. So now we're at kilometers. Yeah. Yeah. Okay, now we have kilometers. So that's done. We've already converted miles to kilometers. Now we have to convert hours to seconds. Notice how there's two problems here. So that's more conversion factors, okay? So Gibbon's got to cancel. So the HR needs to be in the top or the bottom on the conversion factor. Top. And how many seconds are in an hour? Well, let's say how many minutes are in an hour? 60. Okay. So hours cancel. Now let's go minutes to seconds. Okay. So first thing was the numerator or the denominator. There's which one. You just do conversions to get it over to where you want to be. Then you do the other one with conversion factors. And they all are together. So fraction problems are really two problems built into one. So to do this problem, we're going to do, are there any questions about where I got all this junk from? Okay. All right, so we're going 34 times 1. Again, I'm just multiplying everything on the top. Yeah. Okay. So how many sig figs do we got? We got 3 here, 4 here, infinite, infinite. So our answer is going to have 3 sig figs. So that's going to be 154 times 10 to the minus 2 kilometers per second. That's an example of given a fraction, you're calculated to another fraction. Okay, 2 problems built into one. It's always smaller. Yeah, always. It's just that metaphor I gave you with the chain and the link. From the weakest chain determines how strong the whole thing is. It's kind of like this. Doesn't matter how much can it lift. Yeah. Okay, so I'm going to go 34.4 times 1.6 on the bottom. None of the ones don't count. Divide key 60, divide key 60 again, enter. So just however many numbers are on the bottom, that's how many times you hit the divide key. One for each one. And then the ones on the top, it's the multiply key. Want me to put little boxes down?
No.
So you're gonna go 34.4 times 1.609. And because it's on the top, you hit the times key. Bottom numbers, hit the divide key, and there are two of them, so you're gonna divide twice.
Why can't we like one printer?
You can, yeah. It's just more steps. And if you write it down, it's potentially an error in translocating the digits. This way, nothing is written down. It's all internal. Does this make sense?
Yeah.
Okay. All right. That's what I wanted to cover today. Before I go on, are there any questions about how I got these? Okay, again, fractions, two problems built into one. Now tomorrow I want to hit area and volume, because then we get into square meters, cubic meters. Okay, so those are going to be a little different conversion factors. So I want you to practice this. Now, those of you who are tomorrow, Monday, Wednesday, people are going to be starting TriLab 2. I'm going to correct that error I had in the, and I'll send it out to everyone. And I'll print it off as well. Okay. Any questions about anything? Yeah. I am. Yes, I am. And I'm going to leave the metric one off yours. Just kidding. Yes. Yeah, I want to make sure you understand, because it's hard to memorize which is infinite and which is not. So
So you see this whole page is the infinite.
Yeah, on my conversion sheet of it. Yeah. And on, if you look on lab 2, it's italicized. So it's hard to tell. Mine are boldface and italicized. So for me, I just said this. I didn't like it because it wasn't bold enough, so I just redid it. And then I gave a bunch of examples on the metric as well. They don't give any example. So of course, one example. Wow. All right. So I will see everyone in 104. That's on Tuesday lab. And I have to break down all this. So I'll turn this thing off. You have you have 1 week to do it. Yeah. Yeah. No, you're gonna be assigned lockers tomorrow or Thursday. So why don't you wait on sending that in, because you don't have a locker yet.
Where do we get?
Bookstore. However, today you can just download it if you want.
Just print out.
Well, not that, just lab 1. Yeah. Yeah. Mhm. Lab two, right here. Now I redid this. I put my conversion sheets a little longer. And the ones that are, see, this is by definition, see, it's barely italicized. Mine, I have big bold face.
And then it wasn't the calls we spot under the file. But it's like so slow in here.
Don't go by important length.
What's that?
The meat in Canvas is files, modules. Those are the two main ones, and assignments as well. Those,
Person chart name. You know, the file name of it?
I just have it embedded in lab two, but I'm gonna move it out as a separate one.
Okay, good, thank you.
Exactly. So you're gonna go that times that times that, hit the divide key, Oh, sorry. And then do sig figs.
So it would be just.
Exactly. Yeah, got it.
Something like that. If for something like this, like let's say like this wasn't clear, it's just like convert like 12 inches to like 1 feet. It goes like from 12 inches to 1 feet, but this is like two significant figures. Would this be like 1.0? Like
Exactly. You have to put the zero there to make it two sig figs.
okay,
Otherwise, it's only one sig fig.
yeah. Oh, also it's like everything we turn in, like we don't like turn anything like physically. Everything we turn is on Canvas, right?
Yeah.
Yeah.
Everything is an upload.
Okay.
I had a question. So for this one, what is the cost of 1.5 pounds of sugar?
Mhm. So this is your conversion factor right there. See the per? Per means fraction.
On top, and then per pounds.
Yeah, but what's given though? Stop. What's given?
2 pounds,
No.
Yeah.
1.5 pound is given.
1.5.
Yeah.
Oh,
So that we start with.
you don't start with the fraction.
No, because that's a conversion. See, that's a fraction.
Yeah. That's how the other one was set up, huh? So you do
Start with 1.5
LBS.
or LD, it's fine. No, that's it. That's the
That's
given.
it?
Yeah, the given is just by itself. Unless the given is a fraction. So
You could've just split.
yep. Because it's two sig figs, so it's 4, but you have to give it two sig figs. Yeah, right, exactly. You got it.
Then if you're trying to cancel out the pounds, so you put it at the bottom.
Yeah, so it's gonna be 2.0 pounds. And on the top is gonna be $2.45. Then you notice the pounds cancel and you're left with what? Money. Yeah,
And then that divided by that times that.
yeah, or that times that divided by that. Same,
Oh, okay.
same thing, yeah. No, no. You need to purchase the textbook. Now, what's online is the lab 1 and lab 2.
Okay.
Because sometimes the bookstore is out of them. And then also because it's summer, everything starts so fast. I just want to include it. So,
Okay.
no. The practice ones go to Canvas, Files, Unit 1,
Okay.
and you'll see them all there.
Gosh, it's so pretty.
Hmm?
I still think it's a textbook.
Yes,
Okay.
I think you should, yeah.
Okay.
Because the textbook follows everything I'm doing. Like we're in chapter 2 right now. Wait a minute, start over. The lab is Tuesday, Thursday, but lecture is every day. Okay, is that what you're asking me?
Yeah.
Correct. You're welcome.
But like here we have four images.
These are by definition.
Okay, we have something about by definition and something not, but I don't know what is.
If you look on my sheet, on my sheet, conversions, the ones that are in bold are
Well, good, like there.
are by definition. The ones that are not both those are measured.
Mhm.
So then those, that's like
Okay,
different.
okay, right now I'm
Better.
yes, yeah, thank you. And
Sure.
also, I'm today, I was today late. Is your marking is absent?
No, I forgot to do attendance today.
Oh,
So everyone was here.
yes.
You're fine.
I'm sorry.
But you know, that comes into play for waitlisting. In fact, I'm not gonna take attendance anymore because we don't have any waitlisted people anymore. Everyone got in. So there's no need to take attendance anymore. So,
Still, I'm sorry.
no, it's fine. Bye-bye.
Is it okay if we do it?
But the problem is you have to create a PDF file. But it depends on how you view them online.
And how I save it.
But we might have just answered this, but so our homework, like lab one is due on the 17th. Is that right? Okay, and so you're saying it's kind of easier to pull it out on paper and then upload it as a file via. Can you say it's easier to do it that way?
When you're submitting an assignment, you can only do this. You want to send the file. Don't do it. with Canvas. You can send a message, but not a file. I mean, you can do it and it'll accept it, but it won't necessarily go through. I found it more like, but in Outlook, you know, drops off.
So when I here start assignments inside Canvas, it's something like this is gonna pop up, this right? It just box of like uploading files, so if I do this on sheet, I just need to scan it.
Yeah,
and then-
that's exactly.
Okay. All right.
Yeah. It was 6 pages, around 5 different. All of them. Don't give me 5 separate files.
Right, so,
Keep adding pages to the PDF.
yeah.
Most scanner apps say add page.
Okay, it looks like that.
Yeah, I think I need a better scanner app. Do you have one that you recommend?
Are you Apple?
I'm both, actually. I have Dell. Okay.
I'm Android. So,
For one
the one I have is, works fine. I've been using it for a long time.
Oh, yeah, that's why, I mean, I could go up with the app on my Dell.
That's
That's
not.
that way, but I, separate. Like, yeah,
This, but that's what we did.
Yeah, a lot of people just use, look the app on their phone and then use that to scan and then save it up and then send it to yourself.
That's the, so you don't need to convert it to that because it says.
Problem I have on my phone, I save files on my phone, sometimes I can't find.
Instead of the,
right.
Depending on the app where it saves it.
I know.
That
It's
one's
not
better
very
than.
consistent.
Yeah. it's
I
not-
just want to.
So if you have a scanner hooked up to your Dell, that's the way it works.
No. I have a scanner on my printer, but I don't know how to use it. I
Oh,
figure
that's,
out, but that would be ideal. That would be the easiest.
yeah, get that to work. What's that? Brother time?
Thank you.
Okay, just go in there and say, how do I get my? HP scanner? No problem.
Okay.
Cause I have, that's what I. Scanner combo.
What app did you say you are using? You are on your answer. You probably have an
I didn't, you said-
Oh, there's a
Um,
Oh, you do.
This is the one.
No. I have one of my phone called Titan Scanner. We can't just like, it has to be. Okay, and what if we just like took a picture and saved it? Yeah, would that be?
That's why the problem is getting both.
Sorry, I just lost the name again. You said, you just told me.
Turbo.
Turbo. Thank you.
Sure. Yeah,